So my talk is really going to be about 3 things, I guess, maybe 4 things. Number 1, I'm going to do an introduction to EigenLayer. Number 2, I'm going to do an introduction to a tool called Waves, which is an abstraction on top of EigenLayer that allows you to build services verifiably a lot easier. And number 3, we're going to be looking at kind of like a vibe coding prompt that I created to do a one-shot creation of a service. And number 4, we're then going to try to live code that using Claude Code. And I would give this about a 75%, no, let me be more. I would say I would give this about a 50% chance of working because I'm live coding and demoing in front of people. I've tested this prompt a bunch of times and it's worked about 95% of the time, so I'm giving myself some leeway. But hopefully it works out, you know. And then one thing I want to actually do to modify the presentation is by just bringing up this visual here, which I'm going to touch on in just a moment. Okay, cool. So to start the presentation off with EigenLayer, I'm pretty sure most people here kind of know about EigenLayer, but a lot of people maybe don't have a very great understanding about it. So part of what we're doing right now is trying to really dive in and polish and dial in what we use, or the language we use to kind of explain EigenLayer, and part of what I want to do here today is kind of along those lines. So when people think about EigenLayer, a lot of times they think about restaking, because when EigenLayer was first created, there needed to be economic security that would then be the means to the end to build what the original vision was. So I guess an analogy of what you might kind of think of in a sense of like you need one thing to exist before the other thing to exist. With EigenLayer, we needed to have pooled security in order to make it available for applications to build. It would be if someone like forked Ethereum and they launched, you know, another version of Ethereum, literally just forked the code base, and they have a couple of validators running or something like that. And then they went to a conference and they were like, hey, you should build your application on our blockchain. But there's no security for that application, so why would anyone do that, right? Instead, you would probably need to first validate your idea, bring on validators, literal validators, launch a token, have investment, have money, and then that valuation of that token would then provide the security for that network, right? But you wouldn't start at the end, you would start at the beginning. That's kind of like how restaking became known as part of EigenLayer, but ultimately, what we're here for is for building developer platforms and essentially unleashing innovation and making it easier for developers to build applications. So when you think about developer platforms, there have been quite a few that have really gone from like either 0 to 1 or a 10x improvement. So when you talk about software or any products, and you talk to a VC or someone that is going to be investing in your company, they often tell you that the thing that you're building has to be 10x better than anything else that exists before for you to be able to kind of pull people away from those previous existing things, or they need to be a 0 to 1 product. Those are kind of the 2 main things that venture capitalists are looking for to invest in your product, because if it's just slightly better, it doesn't really make a difference to the point where you're going to be able to kind of like have people leave another platform to come into your platform, or leave a product because you have that lock-in, right? So if someone wanted to build a competitor to Notion, it would have to not only have all of the features that Notion have, but it would need to be like 10x better, because a lot of us are using Notion or we're using Airtable. We have these products that were like really ingrained into our workflow, and if it's just slightly better, it makes no sense for us to leave, right? So what are some examples of developer platforms that really move the bar? I think the first one would be the iOS combination of the App Store, Xcode, and the, I would say, programming languages, Objective-C and Swift. If you wanted to build a mobile app before this existed, it was almost impossible. There were probably more people, like I would say the same amount of people maybe in this conference that knew actually how to build mobile apps before the App Store existed on this entire earth. Like maybe like 100 50, maybe a few hundred people that could build a mobile app before these actual platforms existed. What Apple did was they realized, okay, we have this device, everyone has it in their pocket. How can we make it to where we can unleash innovation for anyone to kind of come up with an idea and make it available for them natively on their device? So they decided to build not only the distribution mechanism, which was the App Store, but they also had to actually build the developer tooling, which is Xcode, and then the supporting programming languages that they either built or supported, Objective-C and Swift. With the App Store and Xcode, you could download Xcode, you could start with a starter project, you could literally write a few lines of code and launch an app to the App Store and have distribution to all of these people. This just really changed the game, and it made a lot of people excited about software development, including myself. In fact, the reason I decided to learn how to code was because there were so many people building and launching apps. I was like, oh, I want to build an app, and it's so cool, like, I want to learn how to code. So this unleashed innovation for mobile applications. You also have cloud. So before the cloud existed, if you wanted to build and scale an actual service globally to tens or hundreds of millions of users, again, there were literally probably a few hundred or maybe a few thousand people on the earth that could actually show you how to do that. Because you needed to actually do an insane amount of work to make your service not only stable and reliable, but also, I would say, with enough like low latency around the globe to make it usable, and therefore it was just really, really challenging. With AWS, with Google Cloud, and with Azure, you can actually now spin up databases like DynamoDB that handle tens or even hundreds of millions of operations per second. You can spin up services like on AWS Lambda that will auto scale for you and scale down depending on how many users. So it makes it trivial. The only thing you have to focus on now is writing for the most part, like your business logic. Like what is the actual differentiating product you're building? You don't have to worry about what they called undifferentiated heavy lifting. So this paradigm is how 95%, 99% maybe of software companies build now. So this is an insane amount of innovation that's kind of been unleashed. And then you even have developer platforms on top of developer platforms. You have Vercel, you have Cloudflare, and these other abstractions. Vercel is actually a customer of AWS. So when you're using Vercel's functions, you're actually using AWS Lambda under the hood, to the best of my knowledge, at least the last time I checked. I know they've released a couple of new products lately, and I don't know their infrastructure. But with Vercel, I can go and I can download a Next.js project, and I can like type in one command in my terminal, and it gets deployed to this global CDN. Everyone in the world can use it. Automatic CI and CD. I upload my code to GitHub and make a change. It gets redeployed. It's just an insane, like 100x better improvement than what we maybe would have done 10 years ago. We might have written some code, compiled it, uploaded it to like an FTP server, right? And we wouldn't even have had like a CDN or anything at that point. So anyway, so these developer platforms, they really unleash innovation. So I can say, I'm gonna go vibe code an app now. I'm combining AI with Vercel. I can upload it, I can get it in front of the entire world, low latency, it scales, boom, everything is great. So in the blockchain world, what is the analogy there? Well, it's basically smart contract blockchains or programmable blockchains. That's kind of where we are at the moment. Before Ethereum existed, if you wanted to build a blockchain application that was different, you literally either had to fork or build a new blockchain from the ground up. Bitcoin, Litecoin, Namecoin, there were dozens, maybe hundreds of these slightly different networks that existed before Ethereum. But you couldn't build an application on them. You had to fork them and then change something, and then you had to bootstrap that whole process from the ground up. And obviously there was very limited innovation there because it was just a hard thing to do, and very limited number of people that knew how to do that. With programmable blockchains, you write a smart contract. You can literally take an existing contract, make one line of code change, and you now have deployed a brand new application, and it takes 5 seconds. But what you're doing with Ethereum or programmable blockchains is that you have all this underlying pool of economic security that you're inheriting. You don't have to go and start a new network. You don't have to launch an ETH token. You don't have to do all this stuff. You're kind of just launching an application. You're inheriting that economic security, right? So with that in mind, that's a good analogy of kind of how EigenLayer works. And I'm going to dive into, let's dive into a little bit more there. So with EigenLayer, Turn the slideshow back on. There we go. So there we go. So we have like the application-specific blockchain paradigm. You build the network from scratch. You have now programmable blockchains where you can write a smart contract. You're inheriting that underlying economic security. And then we have the roll-up era now, so you can kind of like modify your execution, but you're still inheriting the underlying consensus and security. So you can actually deploy an SVM or a move VM or a different EVM to this underlying network, but still inherit all that security. But this is extremely limiting, even at the programmable roll-up stage. Why? Because we're building within the constraints of a blockchain virtual machine. If you're building on Solana, on SVM, if you're building on Move, on the Move VM, on Aptos or Sui, if you're building on Ethereum or any EVM, you are constrained in the sense that you cannot make external API calls, you cannot do complex computation, you cannot do complex GPU. You can't even talk to other blockchains, right? You're just like extremely limited. And people ask like, why has innovation been so stifled in the crypto space? Why haven't there been killer apps? Well, we don't have much to work with. We're just extremely limited on what we can do. So the idea for EigenLayer in general is essentially, okay, we have all this underlying economic security, but we're constrained within this network. What are people building already that are kind of like already expanding beyond a smart contract? Well, let's talk about, I guess, oracles are a good example. If you want to talk to the outside world, you can do that from a crypto, I would say, from within a crypto virtual machine, right? If you want to, for instance, say, get a price feed from some oracle, like Chainlink or something like that, the way that you do that is you have an event that's emitted, it's picked up off chain, something happens, and then it sends it back on chain. Now, how was Chainlink built? Well, Chainlink was built like Bitcoin was built. It's literally a completely new network from scratch. So if I'm like, okay, I like Chainlink, but it kind of doesn't do everything I wanted, I want to build something slightly different, the task that you now are presented with is literally building that entire network from the ground up, creating a token, bootstrapping validator set. It's an insane amount of work for one little piece of functionality, right? So what if we could instead kind of take the pooled economic security that we have from blockchains like Ethereum and Solana, and then we can combine that with any arbitrary off-chain code that we want to write in any programming language, TypeScript, Rust, Go, Python, whatever, and then we can kind of combine the two. That's essentially what EigenLayer is, or really what shared security ultimately enables. So if you want to, say, build an oracle, if you want to build some type of verifiable inference from AI inference, if you want to build some type of, bridge, if you want to build a coprocessor that does some insane complex computation that is impossible within the virtual machine, if you want to talk to an external Web2 API, I mean, literally anything you can possibly want to do is now instant and very simple in theory. In practice, I'm going to talk about how we're kind of making it a little bit easier. But now with EigenLayer, you can say, okay, I'm going to emit an event. I have this JavaScript. I'm going to pick up the event. I'm going to do all this stuff, and I'm going to send it back on chain. But this off-chain code no longer needs to then be secured by its own separate validator set, its own token, and all of that. I can just go do whatever I want, and I'm making this possible by inheriting this other underlying economic security. Now, does that mean you still don't launch a token for your service or your software or your app or whatever? It doesn't. It just depends. What would be the different circumstances there would be, okay, if you did launch your own network from scratch and you did launch a token, you're probably paying tens of millions of dollars, or even depending on how valuable your network is, millions or tens of millions of dollars per year in emissions for the validators that are running your network. You can pay a small fraction of that to the operators running your AVS. Like when I say a small fraction of that, we're talking about much, much smaller fraction in the range of single-digit percentages of what you would have paid in emissions. And to kind of visualize this, I created this diagram a couple days ago. that I thought was like pretty good, because it kind of really puts things into buckets that kind of make sense to a lot of people. So you have application-specific chains that are very powerful, but they can only do one thing. You now, then to expand the scope of that, you have smart contract blockchains or programmable blockchains that allow you to write your own logic and do everything, but you're restricted by the VM that you're working inside of. So what can you do here? Token transfers, you can store and track ownership of assets. You can do, I would say, trivial database and data computation. You can verify signatures, and you can authenticate users. You can interact with other contracts on the same network. And you can basically build within the constraints of that virtual machine. With EigenLayer, you can literally take all of these things that you can do within a blockchain, because you're still going to be working within a network from to start with, and then you can expand that with anything that you can potentially think of that you would write into a traditional Web 2 server. So I'm going to skip over. Well, I guess I shouldn't skip over. Let me just show this slide here. This is just an idea of like all the different players within the EigenLayer marketplace. So EigenLayer is kind of like a four-sided marketplace you could think of. We have the restaking, which we talked about at first, which is kind of like where the economic security comes from. You then have the AVSs, which are services. AVS is an acronym for Autonomous Verifiable Services. You can think of these as networks. In the past, people used to say chains, but these are not just chains. They're like all types of other things. So you have the security, which is the restaking. You have the AVSs, which are the services. You have the stakers, which are the people actually like staking, the rewards. You have the operators who are actually running the AVS software. So stakers would be the economic security. AVSs are the services. Operators are running the services. That's the third side. And then the fourth side would be the consumers. These are the applications that are kind of consuming, these services. So we started with restaking. We then moved to AVSs, and we've been focusing on AVSs, which are services, for the last year. We now have, I think, around 600 to 700 that we've talked to that are like either exploring or building, and we have around 200 that are building towards mainnet confirmed, and we have around 50 or so that are already on mainnet. So with that, AVSs, that's continuing to gain momentum. We were the fastest growing blockchain developer ecosystem in the world in 2024, and we're hoping to continue that trend in 2025. We're now starting to see more and more applications being built on top of these services. So 50 live services, 200 hopefully coming within the next 6 months. And now we start to have like actual real applications. A couple of examples of those would be Earnify, which is, I think it was the #1 app in the App Store for finance. We have EarnOS. We have the founders of Reddit and Dig are building the new Dig on Opacity Network. Redstone is like an oracle that's built on EigenLayer that has a bunch of applications. I think when we kind of last tallied it, we had around 80 what I would consider like notable applications. But by the end of 2025, we're hoping that number to be closer to like 1,000. So that's a huge focus for us, is to kind of, when I say like notable apps, I'm not talking about like a hackathon project. I'm talking about like an app in the App Store. And then as more AVSs and more apps are live, then the rewards are being paid to the operators, giving them higher yield, which will then attract more TVL, right? So you kind of have this equilibrium where if the people that are staking are earning rewards, then they stick around. If they're not, they leave. But when they leave, the yield goes up, right? So the more AVSs, the more rewards that are coming online, the higher the yield, the more the TVL goes up. But even if the TVL goes down, the people that are still there make more money. So it kind of balances itself out, or more yield. Couple of numbers, staking went way up in 2024, obviously, because it's the year that we launched. Operators, we have 75 of the world's top 100 operators running services on EigenLayer. We're shooting for all 100. AVS developers, we grew extremely well in 2024. We're looking to keep that going this year. And what are people building? Different verticals are listed here, but a lot of this stuff is a little nuanced, like it overlaps, so I wouldn't kind of say that something that's outside of the roll-up services category doesn't actually overlap with that, and vice versa. A big place that we're seeing a lot of people building products that are like fundraising and have some cool opportunities are in the AI space. Sentient, Ritual, Hyperbolic, Gaia, OpenLedger. There's a bunch of cool ones that are being built in that space as well. And then we have EigenDA, which is the most scalable data availability solution. We're about to launch our V2 or Blazor update, which will increase throughput along with a few other things. Yeah, a few of the different protocols that I would note that are building or already live on EigenLayer would be like Layer 0, UMA and Polymarket are building a prediction market oracle. And Fura is building, their a new RPC infrastructure. MegaETH is building on EigenDA, huge fans of MegaETH. Mantle as well. Redstone is one of the more popular oracles in the blockchain world. Hyperland is a cool bridge. I think I mentioned some of these AI projects as well. Aether is really interesting because they actually have revenue. There's not that many companies that have revenue in crypto, right? This number is wrong. It's like $130 million annual revenue as Aether has. All right, so roadmap. I think we're actually already shipped some of this stuff that's listed here, like slashing. So slashing was in progress, it's now shipped. We're working on data availability throughput of 100 megabytes per second, which would be around 75 times more scalable than the next leading option in the space. And really lowering the barrier to entry for developers is a big focus for us. So we want to make building AVSs 100 times easier. A good analogy might be serverless functions. If you write a line of code in TypeScript and you want to execute it in the cloud, you can deploy it to Lambda and it just runs and everything else is managed for you. If you want to build a completely brand new service from scratch, from the ground up, you can go the more complicated route, use Kubernetes, you can use EC2, you can use all of these like more low-level infrastructure tools, but AWS gives you the option to do whatever you like. We are going to be offering the same options. We want to make it to where if you want to just write some code, deploy it to EigenLayer and let us run it, we want to make that possible. There are teams like Authentic, there are teams like Waves that are building great developer tooling that allow you to do this today. So a lot of like ways to kind of build on EigenLayer, and if you ever want to learn more, you can chat with me, but I'm going to be diving into Waves today. So, all right, with that being said, I'm going to be diving into the coding demo now. I think I mentioned, I'm going to mention a couple more apps. I think I mentioned Dig and Earnify and EarnOS. Avo is interesting. Daisy is a Web 2 social application using zk-TLS. Nosh Delivery is really cool because it's essentially just a true Web 2 application, similar to Uber Eats. And the number one focus for me and for the company this year, after obviously security is number one. Number two, I guess, would be developers. We are like really focused on bringing in more developers, building apps and building services this year. 4 ways to build an EigenLayer, I would say. 1, build an app on an EigenLayer AVS, so like building on an existing service like Opacity Network or Reclaim Protocol or whatever. There's like 50 of them, like I said. Number 2 would be building an AVS from scratch. Number 3 would be using a developer abstraction like Authentic or Waves to build an AVS. So you could think of Authentic or Waves similar to Vercel on top of AWS. It just makes it a lot simpler to build and get something to market. And they also have a great team that kind of like helps you out as well. And then finally, EigenDA is a separate product that you can build on that doesn't like have the exact same use cases as an AVS. Obviously, it's just more of a data availability layer, but a lot of people are using it as like a temporary cache. A few different ways that people are using EigenDA outside of like what you might consider a data availability layer would be used for. If you want to get involved, we have the Eigen Alpha Ambassador Program, where we have hacker houses that are going to be continuing to pop up. We're going to be announcing one for Berlin very soon. We have a university program called Eigen Games, and then we have a Build on Eigen group chat that's open for anyone that wants to join. Okay, cool. So now to the live coding demo. So I mentioned that the whole ultimate goal is to make building off-chain or bringing information off-chain or being able to kind of like write off-chain code and make it verifiable as easy as possible. We want to take the best properties of a blockchain, which would be security and verifiability, and we want to pair that with the best properties of building just traditional software, expressivity. I can talk to a database, I can talk to an API, I can call an AI inference service, I can work with some very, very computational heavy GPU. I can do literally anything I want in the whole world. We want to combine those two things together. So the tool that I'm going to be using today to make that happen is called Waves. Waves is essentially an abstraction on top of EigenLayer that allows you to just write your business logic. They have their own operators and everything. You just upload your code to their service and they run it on EigenLayer for you. It's kind of like the serverless functions of EigenLayer. You could kind of think of it in that way. So the way that we're gonna, and the programming languages that they support at the moment, I believe are Rust and Go. I think Rust is probably the most supported programming language though. So when you start off a project with them, they give you kind of a few boilerplates. They have like maybe 5 or 10 really cool boilerplates that you can start off with. But the two most, I would say, common ways that people start building with EigenLayer, and two of the more common use cases are oracles and they are bridges. So an oracle, again, would be like, I'm emitting an event for my smart contract that says something like, give me the final score of the Bulls game from today. The oracle picks that up and it goes and finds the score of the Bulls game because that's not available on chain, right? Then it pulls it back on chain by writing, writing a transaction back to the network, and then I pick that information up, and now my blockchain application has that information. So that's the general idea of an oracle. You make a call, you made an event, you pick that up off chain, you do some stuff, and you bring it back on chain. But that could be anything. Like I can talk to any API, right? So in our case, we want to transform this oracle into an AI inference service. But you can't just do AI inference off chain, because the whole idea of having a blockchain is verifiability. And for verifiability, you need some type of, I would say, determinism. You can do that in two ways. You can do that with ZK, because you can kind of like verify that the outcome, the output is truly what it is, but it's a little more complicated, it's more expensive, and it's a little slower. Or you can use something like the approach that we're taking that basically uses a combination of a traditional like LLM service like OpenAI along with the seed. Now the determinism of this approach isn't 1,000,000% accurate. I think it's like 99.99, there's like some number of nines percentage that this should work. Meaning that if you have like 6 or 10 or 5, whatever number of operators, and they all run the same query with that seed, they should all return the same exact answer. So if I ask what is 5 plus 5, every LLM will probably give me 10, right? But what if I say, what is the best place to eat good creme brulee in the world? I might get like 10 different answers, but if you want determinism, you can actually make that happen by providing a seed for LLMs that support that, right? So that's going to be the way that we approach it. We're going to provide a seed, and we're going to kind of like take the Oracle service, and we're going to kind of transform that into a verifiable inference. And the way that we're going to do that is we're not going to actually code this. We're going to vibe code it. Meaning we're just going to send in this prompt that will just explain everything we want in one shot, and we're going to let Claude Code write all of our code. And once you kind of like start working in this way, it opens up the door for like a lot of cool shit, right? Because you could then come up with any idea possible, and then you can take this prompt and you can kind of modify it to build anything in the whole like world that you could possibly think of. And that's why I said like this demo may or may not work, because we're essentially asking the LLM to provide us with like 15 or 20 code updates for these files in one prompt. And we're just like, okay, we're gonna do all this and we're gonna run the code, and we hope that it works on the first try, right? That sounds kind of crazy, but that's what we're gonna try to do. Okay, so to do that, we're gonna create a new project, and we're just gonna start writing some code. And if you look here, I don't know if you can see that, it looks like you can. There's basically a Forge, you can use Forge to kind of clone a GitHub repo, right? So we're just gonna use Forge, and we're gonna clone that base Oracle project. And we're gonna use, let's see here. So I'm just gonna paste this here. So Forge init, and we're just gonna pass in the template being the Waves Foundry template, which is in Oracle. So now we have this, this Waves project. Oops, actually I shouldn't have done that. All right, so we're gonna open up this in our code editor, and this is Windsurf. If you've never used Windsurf, this is what it looks like. You have your typical like VS Code stuff on the left. On the right, you basically have your LLM, like conversational prompts available at all times. I'm not actually going to use Windsurf though. I'm going to use Claude Code, so I'm just going to close this. I'm not going to use Windsurf's coding thingy. All right, cool. So we have that. So what we want to do is just build out the Oracle. And here's one of the representatives or founders of Waves, by the way, which hopefully I do it justice. Anyway, if you want to learn more about Waves, talk to him. Anyway, I'm here. I'm going to go ahead and try to run this basic service from the template that was given to me, so we can kind of just run a basic example, and then we're going to modify that. And what this example does, it's kind of I think it's a price feed for getting crypto prices. So let's say you want to know the price of Bitcoin, and you want to bring it on-chain into your application, or you want some random arbitrary coin that literally launched 5 seconds ago. You can do that. You can make that. It doesn't exist, but you can make it, right? Because obviously you're not going to see this supported by Chainlink or these other ones, but you know, if you build it yourself, you can build anything you want. So to kind of get everything set up, I'm going to run make setup, which is just a make command that you can actually go down here into the make file and check out. And what I would say is actually, if you're building with Waves, the first place I would go would be the make file, because all of the different commands that you can do within the project are all located in the make file. And it also has a lot of like helpful information to help you understand kind of the underlying infrastructure of Waves. And when you look at this Waves program that it's given us, it's actually very, very verbose in terms of like how much boilerplate is there. But this is the case with a lot of great, you know, software starter templates, right? If you've ever built with React Native, you start a new React Native project and you have an insane amount of like dependencies, but you go into this one file and you write your code and everything runs beautifully. And that's the one place you need to worry about. You don't need to worry about all this other stuff, right? It's very similar here. We're going to go into the components, and we're going to go into, oh, you know what? I'm going to actually delete this project because I think this is a project that I've already built before, and it's not going to actually, I need to basically start over again. Just give me 1 second. Oh, you initialize a project that already existed? Yeah, that's kind of what happened. It's okay, it takes 2 seconds. Okay, cool. So we're back into our project here, okay? And I'm gonna go ahead and run make setup again. All right, and now if I go into the project here, and I go to components, you'll see that we have this ETH price oracle here, okay? So this is the file, this is the little area that we're working with, and in reality, the only code you need to really start with is this lib file. And within this lib file, there are like 2 functions that you might even then really want to worry about. Would be the run function and then the function that actually calls the oracle, which is this get price feed. I'm sorry, which calls the API that is essentially the main functionality of your oracle. So this code is very simple to kind of read and understand for the most part, right? You have this get price feed function that calls, in this case, the CoinMarketCap API. It passes in an ID that's been, in this case, set in the make file. And then it just returns that value in like a JSON object, and that's about it, right? So not too much going on there. So let's run this, and before we run that, let's go back to our make file and kind of like look and see where this config is set. Right here we have a CoinMarketCap ID. That is number 1. On CoinMarketCap API, number 1 is Bitcoin and number 2 is Litecoin. So what we're going to do is we're going to start with Bitcoin. We'll get the Bitcoin price, then we're going to go and we're going to get the Litecoin price just to kind of test it out. Now I'm going to run forged build, and depending on the day, this could take a long time or not. Oh wow, that was fast as hell. Okay, good. Awesome. Okay, cool. So the project has been built, and okay, let's actually not test it. What we're going to do now is we're actually going to, let me run this make WASI build. I don't even know if this is necessary, but let's just run it real quick. I think this might be the longer command. Okay, so I haven't gone into kind of like how this is actually working under the hood. So I'll touch on that in a second, and I might not be giving it justice. So maybe, again, if you have any questions, Sam and the founders of like Waves are here, or Layer Waves, whatever. So when you build on EigenLayer today, you're building essentially a containerized, often version of your application, and then you have to find operators to then run that service. And it's kind of a manual process, right? You have to coordinate with these operators, they have to download your software, they have to run it, and then if you have an update, you have to then coordinate the updates. So it's kind of like, a somewhat intensive task. With Waves, they actually have their own operator set. So all you have to do is worry about focusing on your core product or business logic. You run a command, it kind of bundles it up, and then you can deploy it to their operators. And then when you want to make a change, you kind of deploy that update again. It's kind of like, again, a serverless function. You don't have to deal with a lot of this lower level infrastructure. You're just like writing your business logic and deploying it. Okay, cool. So we've run make WASI build, which builds that WASM component, because that's kind of what it is. It's under the hood, it's WebAssembly. And now we can test it out. Actually, maybe that was the command, actually. Let's see here. Okay, maybe the build was just the build. Let's try this one more time. Maybe this was the command. No, that's not the command. Yeah, I think there used execute. Oh, there it is. Oh, okay, I see. I was confused because they're passing in the CoinMarketCap ID as an argument. Okay, cool. So let me just run make WASI execute here, and this will execute. And you can, it looks like you pass in the, you can pass in the ID here, or you can take it from the underlying environment variable. Oh, I need to start Docker. Now Docker's running, I'm going to run this again. What's that?
On the docs, there is like a before process, like 3 more commands. Because I'm running the same.
Are you running into the same issue?
Yeah, and I solved it. Scroll up.
Oh, okay, scroll up.
Yeah, this is the 3 commands. Before.
I have Docker installed and running. Let me just check one thing right here. I'm in the wrong file now. It could be some, I don't know what the issue would be actually. This hasn't get run into me yet. I wonder if there's some problem with, I feel like Docker isn't being recognized in my environment variable or something like that. I mean, in my environment. Let me just see if I can double check where. I'm going to use Claude Code real quick, and I'm going to try to Bob code to fix this issue. And then if not, we might have to like give up on the live coding demo. It's telling me to do the thing that I've already done. So let me try that one more time, and if not, I might give up on the live demo. But I have a feeling I know for sure it has something to do with my own Docker issue instance.
Nader, I think I found it. It's Docker under advanced. Like Docker advanced allow that
What's that?
I think I found an issue. It's under Docker and under advanced. And it's like allow the default Docker socket to be used. Oh, sorry. I think it's under Docker advanced allow that default Docker socket to be used. This.
Yeah, I mean that's what I'm not sure though. Because do you think it would? I've been using Docker for the ever since I got my computer, so I haven't had any issues. I'm wondering if you're saying the configuration for finding it within my path. You think it's like a path issue, or?
I think so, and so right now you're running Docker, right?
Yes.
And there is under the settings like advanced.
Oh, okay. You're saying in the actual Docker settings.
Yeah, the UI.
For some reason, I don't even see it right now. So let me try that one more time. Let me just see if I can close. I don't even see it running. No. Yeah, I think I might have to give up. Well, let me just wonder if that had something to do with this update I made recently with Xcode. I doubt it, but who knows? I don't think this is gonna work. Anyway, so I'm gonna have to unfortunately just quit the demo because Docker not running is actually a problem because it's kind of a big, obviously the big dependency for this. So what I would suggest though is like, if you just have Docker installed on your machine, it should all work fine. If you just like look for Dabit 3 GitHub gist, you'll see that I have all of my gists lined up here for a couple of different prompts. So I have a verifiable AI prompt, I have a sports score oracle prompt, I have a few different prompts that allow you to kind of like create different types of services on Waves. So starting off, you get that coin market cap or that price feed oracle. I have a prompt that can let you create a sports oracle. So if you want to get sports scores and kind of bring them on chain for building a prediction market or something like that, I have an example for that. And then the other one I have is like the verifiable AI inference. So I guess if you do want to see a working live demo of this, I recorded a video of this, and it's on my Twitter as well and on my YouTube, so you can check that out. If it might be even better than this because then you can go back and like rewatch it and all of that. So I guess with that being said, that kind of wraps up my talk. So thanks everyone for checking this out. I apologize that my live coding demo kind of crashed out, which is unfortunate, but it's pretty common, honestly. It's like,
it was Docker's fault. Docker crashed out, not you.
But anyway, so if you have any questions, yeah, come talk to me or talk to Sam, who's also in the building. And yeah, he's waving his hand there. He's one of the founders of Waves. And I hope you enjoy the rest of your week here in Dubai. Thanks.